Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you all to today's session. Today's session is exclusively for my grade 9 elite students as they have their exams coming up. So on their special request, we have a series of trigonometry lined up coming up. So stay glued to the channel, make sure you subscribe and also hit the bell icon so that you don't miss the upcoming videos. The module for today is module 13, lesson 4. We are going to be learning today about double angle and half angle identities. So this lesson is basically covered in two parts. So today we are doing part 1 of it, and the learning objectives of today's session are to find the values of sine and cosine by using the double angle identities. So let's dive into the video and see what we are learning today. Okay, so these lessons of trigonometry students are about learning some important formulas, and any and every question in the lesson will be solved using these formulas. So I have here put a formula sheet for you. This is the first formula sheet of this lesson, which talks about the double angle identity. So double angle, double means twice. So therefore there will be two times the angle theta involved. That's the way to remember. So the first identity is for sine of 2 theta. So it is 2 times sine theta cos theta. Now one important thing to remember here is on the left you have 2 times the angle, double the angle. Whereas on the right side it is single angle. So don't do that mistake of mixing it up. So sine 2 theta is equal to 2 sine theta cos theta. So this theta is half of the double theta. Remember that. Then cos 2 theta. So cos of double angle identity is cos square theta minus sine square theta. Now for cos, this identity takes three forms, this one and this one. And basically these two other forms are coming from the Pythagorean identity that you have already done in your previous lesson, which is sine square theta plus cos square theta equal to 1. So if you replace any one, for example, you put cos square as 1 minus sine square, what you get is this identity. If you replace sine square theta with 1 minus cos square theta coming from the Pythagorean here, what you get is this identity. So these are three different forms of the same identity for cos of double angle, but you may use them as and when needed. So you'll have to decide which form works for you in a particular question. Next, last but not the least, is tan 2 theta. So tan of the double angle identity, which is 2 times tan theta divided by 1 minus tan square theta. Now this formula looks a little different, and it is quite obvious that it is different because tan is sine over cos. So it is a quotient identity. There is going to be division involved. That's why 2 tan theta divided by 1 minus tan square theta. In each of these identities, it is important to know that on the left you have double angle, that is 2 times theta, whereas on the right you have single angle, which is theta. So not to mix and not to make any mistake, please learn this formula sheet in case it is not provided by the ministry in your exam. You should know it under any circumstances. So learn it and it will come with practice. Okay, so let's now solve one question on double angle. Here you need to find the double angle sine for sine. So sine 2 theta you need to find. That means you are going to use the first identity. Let me first write it here. Sine 2 theta is 2 sine theta times cos theta. So that means in order to find your sine 2 theta you need what all? You need sine theta and you need cos theta. Now which one is given? Sine theta is already given, good for you. That means if you are finding cos theta, we are done. So we need cos theta, and that finding is step 1 of the question. So if sine theta is given, how can you find cos theta? How are sine and cos related? Yes, you are correct. They are related by Pythagorean identity. So their sum of squares is equal to 1. So if I want cos from here, I can write as 1 minus sine square theta. Now, is sine theta given to you? Yes, it's given. So we can plug in that value, take its square, don't forget the negative sign, simplify, and this whole thing comes out to be 65 over 81. Now, this value 65 over 81 is the value for cos square theta, but we need cos theta. So we are going to take square root, and when I take square root, you get plus minus square root of 65 over 9. Now, in order to choose which sign we have to take, you have positive, negative, both. Step 2 would lead us to determining the correct sign. Now, to know the sign, we are going to use this information. Something about theta is given to you. What is given? Theta lies in this angle, 180 to 270, means it is lying in third quadrant. Okay, so what should be the sign? Let's decide the sign. So if theta is lying between 180 to 270, that means 2 times theta, let's double it up, is going to lie in the range of 360. So I'm multiplying everything by 2 here, times 540, right? So that lands us that 2 theta is in quadrant 1 or quadrant 2. So in both quadrants, whether it is quadrant 1 or quadrant 2, you have sine of 2 theta as positive. So if sine 2 theta is positive, so our answer will have positive sign. So that completes step 2 where we have got the sign. Now that we know the sign, let's find the final thing. So sine 2 theta, we are going back to our first formula that we started with. So 2 of sine theta minus 4 by 9 and cos theta. So for cos theta, we are taking the value as negative square root of 65 over 9. So you have got all of these values. And why we have selected cos as negative? Because in third quadrant, cos is negative. That's why you have selected that. I hope you remember the sign convention. Briefly, I will just draw it here for you in case you have forgotten. After school to college. So this is your first quadrant, second quadrant, third quadrant, and fourth quadrant. Starting from 0 to 90 to 180 to 270, coming back to 360. So this quadrant is third quadrant where only tan and cot are positive. That means cos is going to be negative. So now you just simplify, negative negative becomes positive, solve it up, and this comes out to be on multiplication 8 times 65 over 81. So that's your final answer for sine theta. Okay, so let's solve this question together. Here cos of theta is given to you and you need to find tan of 2 theta. So definitely this is the double angle identity. So formula is 2 tan theta over 1 minus tan square theta. Let's mark this number 1. Now in order to find this tan to theta, we need the value of tan theta. And in order to get this tan theta, we need the value of sine theta and cos theta because it is the division of these two ratios. Now cos is already given to you, but we are not having sine. So if we are able to find sine, we are done. So a step 1 of the question would be to get our sine theta. So if you have cos theta, how can you find theta? How can you find sine theta? Just reflect on that. Yes, you can find it using the Pythagorean identity. So the sum of squares of both of them is 1. So from there you can get sine square theta as 1 minus cos square theta. So just plug in the values. 1 minus cos is given to you as minus 15 over 16. When you take it square, it will become 225 over 256. Subtract them and what you get is 31 over 256. Now this is the value of sine square theta, but we need sine theta. So we are going to take square root of 31 over 256, which is square root of 31 over 16. Now let's decide the sign. Theta is lying in 180 to 270, means if I do the quadrant design 0, 90, 180, 270. So third quadrant. And in third quadrant, after school to college, sign is negative. That means the negative sign is considered for sine. So you have sine, you have cos. Let's find tan now. So tan of theta is negative 31 over 16 divided by negative 15 over 16. So this is given to you in the question. So we change division to multiplication, take reciprocal, and now your negative and negative becomes positive. 16 and 16 is gone. So you have tan as square root 31 over 15. So you have tan. Let's now put that all in the first formula. So we need tan square in that, so it will be 31 over 225. So that's the denominator. So let's now plug in. So tan 2 theta is 2 times tan theta. This is coming from here, and then 1 minus 31 over 225, which is coming from here. Okay, so let's simplify. Now this is mere calculation that we are doing. So this is 225 minus 31 over 225. Simplify your answer a little bit. So I'm going to use the calculator here. 225 minus 31, that's 194. And now you simplify it a little bit more, and the answer after simplification, this 15 and 115 from here is going to cancel, so the answer, final answer, would come out to be B part. So just double check your answer, finish up your calculation. Today's short session on double angle identities. I hope you found the session useful, and if you did, make sure you subscribe to the channel, give the video a thumbs up, and don't forget to share it with your friends so that they can also benefit for their coming exams. Coming up next on my channel is going to be part 2 of this session, which will have the half angle identities. So stay glued and press the bell icon so that you don't miss any notification. Until then, this is Ms. Ruchika signing off from today's session. Bye-bye.